now. So is it recording? Excellent. All right, so welcome to Math341 Probability. In case you haven't figured it out, I'm Professor Miller. I used to tell students that if you knew probability, statistics, and basic programming, you would always have a job. You may not like the job, but you would always have a job. I can no longer promise you this because, unfortunately, someone sued her school when she did not get a job upon graduation. Because of the Freedom of Information Act, you can actually read the lawsuit, where she misspells words like tuition, as well as discovers a new type of discrimination, academic discrimination, that her school did more for people with high GPAs than low GPAs, and her 2.6 is just as good as someone else's 3.6. So I will no longer promise students, I'm sorry, that you will have a job when you graduate. I will say it is extremely likely. I also know a lot of students who have taken these classes with me who are now working at Goldman Sachs or the analysis group. Analysis group will be visiting us on Wednesday. Goldman will be visiting us later in the semester, who love this school and love what Williams students can do. And if you are interested in careers like this, they are very happy to talk to you. And just let me know. So the first one will be next Wednesday. One of the advantages you guys have is you are much more rounded than people who do nothing but quant classes. And eventually it gets to the point where you need to talk to people. You can be the technician working in the basement, that's fine, but you want to be able to communicate. Is there anybody here thinking of being a professional mime? If so, don't speak up. Okay, so no one is really considering a career in mime, so you're going to have to present information. For those of you who do not yet know about the math stats major, we require all of you to give a public talk before we let you graduate. We are the only department that still does this. And it is a very valuable skill to learn how to talk about a technical material for 30 to 40 minutes in front of a diverse audience. You may be in a situation where you know more math than your boss, and you have to convince him or her that you are correct. How do you present material? This is extremely important. And this is one of the skills that you guys have by the nature of the classes you're taking here. All right, so what I want to do now is just quickly introduce the objectives for the course and what we're going to do. So not surprisingly, we're going to study probability. We're going to model the real world. And what's nice is you will know enough by the end of this semester to apply what you've learned in non-trivial ways. You do not have to be the best in the world. You do not have to get the optimal answer. You just have to do better than other people have done before. And as long as you... That was too high of a standard for some. Okay. If you can do better than other people have done, that's already enough to be valuable. So I serve on a regional school committee, and I will tell you how some of the math that we're going to do led to Williamstown and Lanesboro agreeing to regionalize. There are other things I will tell you about the process when the camera is not rolling. But what happens when you actually try to use math in the real world? Some of you have done math consulting with me, working on a multi-million-dollar Major League Baseball lawsuit. There are opportunities like that. And if people are interested, as long as you are willing to work hard and sign non-disclosure statements, you can actually apply the stuff you're doing in some very interesting settings and get access to fascinating data sets. All right. So I want you to learn probability. I'm going to emphasize the techniques and asking the right questions. So most of the time, once the question is asked, it's trained monkey work. I went to grad school, I was trained to do certain things. A lot of people went to grad school and were trained to do certain things. We all know how to tackle things similarly. So if we're told, hey, investigate this, a huge number of us will all get to the same answer. The difficult part is asking the right question, is figuring out what should we look at. So I'll tell you some of the stories from applying math as a consultant. What was the right question to ask? What questions were people not asking? And a lot of times people were just assuming things had to be done a certain way, and you need that fresh perspective. We'll do some modeling, and we'll analyze our models. One of the things you really want to get a sense of is which parameters matter most, which things really control, and which things can you be a little bit cruder in terms of estimating. Elegant solutions versus brute force. There are a lot of things where you can just have the computer run, and in a reasonable amount of time, it can just crunch through all the possibilities and tell you this is the answer. Sometimes, though, they won't generalize. And what you might be able to do is you might be able to do some small cases, build up some intuition, and then see how to go from there. I'm finishing up a research paper with some undergrads and some high school students, and the final paper is very different from the earlier versions. So we did a beautiful job when d equals 2. We had beautiful combinatorial proofs that do not generalize. And the problem is when we were looking at 2 dimensions, it was small enough that we could see what was going on, and there were additional symmetries. And these did not generalize. So it's often a real challenge to figure out what is the right way to look at something. One of the other things I really want you to get a sense of is how do you look at an equation and get a sense of what it's saying. So I will be doing a lot of examples from baseball just because it's probably the most studied field where math is being applied. Out of curiosity, how many people are baseball fans? How many people are Yankee fans? Okay, you do understand what you're getting into? Okay, making sure. So that is not a protected category on campus. Football fans. Although I'm less so because of all the injuries. Tennis. Water polo. Soccer. Hockey. Basketball. Oh, a lot of basketball, okay. Analytics is coming in a lot more in basketball these days. Celtics are one of the good teams to start really moving this in. A lot of it is, can you convince people to do things? There is a huge tendency to do what's been done before. The tall blade, fails the lawnmower first. If you do something non-standard, you expose yourself. And a lot of people will keep doing what everybody else does because it's safer. You won't be blamed, even though you won't have the opportunity for the success. It's very rare to have an organization, sadly, that supports people to take these chances and to take the big picture that you will occasionally lose. Any Patriots fans here? There was a game, Patriots-Colts, a couple of years ago, where the Patriots had the ball in the fourth quarter, and if they could get one more first down, they could run out the clock and win the game. And the Patriots decided to do that rather than kick the ball and give Indianapolis bad field position. It didn't work. They were stopped. Peyton Manning had a short field, marched down, scored a touchdown. The Colts won. And the next, after the game, and the next day, all the reporters are asking the Patriots, "What did you do this?" And the normally loquacious Bill Belichick was actually terse for once and just said, "I did what I did because I thought I gave my team the best chance of winning." Next question. The computer simulation supported him. It increased the chance of winning by about 4%. But most people would not do this. People do not go on fourth down nearly enough. People in soccer don't pull their goalies nearly enough. For the most part, does it matter if you lose a soccer game by 1 goal or 2 goals or 3 goals? No, I mean, if it comes down to tiebreakers, yes, but for the most part, a win is 3 points, a tie is 1, a loss is 0. There is such a difference in going from a loss of 1 goal to a tie than a loss of 1 goal to a loss of 2 goals. You should pull your goalie more often. I was having a conversation with somebody, and I didn't realize for a while that he actually owned one of the Major League Soccer franchises. And he was just decrying the fact that he couldn't get the players and the coaches to do certain things. Just, you've got a situation where the owner says, please do it. But people just have such an instinctive fixation on, well, this is how things are done. So I really want you to get a sense of how to look at things and know that there could be other ways of doing things. And trying to get a sense of what are things telling you to do. So there's a lot of different types of problems we can look at. If there are things that are not on this list that you want, just let me know. And I'm happy to adjust the examples we do based on what you want to study. One of the nice things, because I record all of my lectures, is we have the opportunity to do a partially flipped class, where maybe once a week I will not give a standard lecture, and I will just say, watch the video for the standard lecture, and just have one class each week where we just do additional problems. Do problems on the board, discuss things, discuss other things like that. What you want to do is you want to use time effectively. I am assuming you all know how to read, right? It's not a great use of time for me to be spending class reading definitions. You should have done this before you come to class so that we can use the time more effectively. So the more we can do stuff like that, the more we'll be able to get into problems you like. How many people like to gamble? I don't like to gamble. I like it to be a certainty when I do it. So we will talk a little bit about stuff like that, but there are lots of applications to mathematics and gambling, and in fact, a lot of probability theory was developed by people who were interested in gambling. All right, so this is a subset of my applied experiences. So I've done some work in marketing for movie distributors. So does anybody know how a movie theater makes money? How does a movie theater make money?
Selling tickets.
That's one way.
Junk food.
I'd prefer to say reasonably priced refreshments, but sure, you can call it junk food at sky-high prices. Which do you think they make more money from? The junk food or the ticket sales? The food. And in fact, when you look at the contracts they have with the people who own the movies get the lion's share of the ticket sales in the first few weeks, and then typically as the movie's been out longer and longer and longer, the theater gets a higher and higher percent of the ticket sales, well, but fewer and fewer people go. So when Star Wars The Phantom Menace came out, George Lucas basically told people, if you want my movie, you've got to show it for this many weeks, it's got to be in your best theater, and your sound system must be at a certain level or people will not appreciate Jar Jar Binks. And some people decided, you know what, it's just not worth it. So many people are going to be showing this movie that the amount of money we're going to get from this is not enough to justify eating up our two biggest screens for this many weeks. How many of you live in a place where they often have movies for $1? There are some movie theaters that show old movies for $1. And especially if my parents have retired to Arizona, if you're in a hot climate, going into an air-conditioned movie theater, not a bad idea. They don't really care what's being shown. They want to sell the popcorn, the soda. So I've done some work with movie theaters to figure out what is the optimal movie schedule to have. Which movies should they buy? When should they play them against each other? You need to estimate what is the probability of people going to see a movie as a function of time of day and as a function of what other movies are being played. Another thing I've done a lot of work with is data integrity. When I was a very young postdoc, I got an email that began, "Greetings, my name is David Kelly. I'm a senior criminal investigator at the IRS." About 5 minutes later, I finally had enough courage to read the next line, which was, "I just read with interest your recent paper in Acta Arithmetica." And I was, such a young professor, the fact that anybody would care to read any of my papers was, right? So there's a lot of work that's done to detect whether or not you can trust some data. And so I've done a lot of work. I've actually gone to the headquarters of the IRS in Boston and given lectures on how you can use. These are lectures you give for free. You would much rather have friends at the IRS. And so how do you tell if somebody has made up something? If you flip a fair coin 100 times, what can you tell me should be true? Or approximately true? Yes?
About half heads.
About half heads. If you got 83 heads, would you be a little suspicious? Okay, so we have some instinctive notion of what to expect when we flip coins. But a more refined question, what should be the longest run of heads when you flip a fair coin 100 times? How many alterations should you get between heads and tails? Most people don't know the answer to that. We can calculate that using the techniques of this course, and these become great ways to tell if we have a real data set or a fraudulent data set. I'm just making sure the video is running and recording. Perfect. Okay, so I've done a lot of work and stuff like that, supervised a lot of theses and projects here. The last is baseball, but there's many other things I've done, applying mathematics to stuff like this. So Bill James, people like this, I've been able to meet and get my students to meet people like this as you try to use mathematics to solve problems like this. All right, course mechanics. So we're going to move at a fast pace. You are responsible for reading before class. So 5% of your grade is going to be, I think, just being prepared for class. Homework 15, midterm 40. If there are 2 exams, 2 midterms, I will only count your best score unless you tell me otherwise. I taught at Brown for 4 years, and there were students who actually wanted to fail classes occasionally, because a C would show up on your transcript, but a fail would not. And so I will give you the option if you want me to count the lowest score, but you have to tell me. Otherwise, I will just automatically drop whichever score is low. I will also drop whichever homework helps you the most. Not all homework assignments are worth the same number of points, so whichever homework is the worst, percentage-wise, may not be the best one for me to drop. I will also give you opportunities throughout the semester to earn homework exemptions. So there is a talk today at 1 p.m. in Physics 203 by a friend of mine, Keith Conrad from the University of Connecticut, on the ABC conjecture. If you come to that talk, you are excused from 1 homework problem. You will keep track on this. It's on the honor code for you to keep track of how many homework exemptions you have. They are transferable to other classes I teach. I had a student who in his senior year smiled 2/3 of the way through the semester and said, I'm cashing in. I had taken a bunch of classes with me over the years and was just done. Absolutely fine. I do not believe other professors accept them. If you have family members who are coming to Williams, we can talk about maybe if they are exchangeable. But you can save them for future classes. You can save them for weeks when you know you're going to be very busy. Any seniors here? All right, so for those of you who are seniors, if you haven't been told yet, you have a 5th class. It's called applying for the rest of your life, either grad school or a job. You're going to be potentially running around. All deadlines are negotiable. Just let me know if you can in advance. I know sometimes you find out literally a few hours warning that you are now traveling to New York or maybe even across the country. So I am happy to work with everybody about adjusting deadlines. I urge you to read ahead. Build up a strategic reserve so that when things happen, you have some flexibility. But which is more important, a homework assignment or reading up for a job, reading up for the job? So all deadlines can be adjusted. Prerequisites, Calc 3. If you know some basic combinatorics, that's great. Linear algebra is another prereq. Unfortunately, Williams has not been able to tell us when rooms will be available for TA sessions, so we do not have the official times for TA sessions yet. When we know that, we will let you know. I am not choosing my office hours yet because I know a lot of you have schedules that are in flux, so I want to wait until you know when your schedules are before I set my office hours. If I'm in my office, though, it's usually office hours. You can send feedback to me anonymously through evesmath@gmail.com, password 1793Williams. All I ask is you not change the password. Right? Somebody did that once and it was not pleasant. It does not have to be feedback about this class. If there's something else going on that you just want to bring to someone's attention, by all means, please feel free to use that. All right, so there will be a web page with a lot of information. I've taught this course many times, so what I will probably do is I'm not going to adjust the additional comments after each class. I'm going to just post the ones from the last time I taught the class. Every now and then I might use clickers. Sometimes I might just have people just do it at their seats and just trustworthy, so it's not spending class time going back and forth. I am unfortunately not in this room immediately before teaching. I'm running from another room and setting things up. So we'll be using the probability lifesavers. I might give you some opportunities to create homework problems if you want. And that's a really good way to get a sense of how well you understand the topic. When I was a second semester senior, I was taking a graduate complex analysis class, and for fun I wrote a take-home final for my professor, and when he gave me his final, I gave him mine. 3 of my questions were the same as his. After a while, you start to get to know what are reasonable questions to put on. It's a great way to study. We will gather and analyze some data sets of interest. If you want, you can choose a project to do for this class. Almost anything will count. I'm extremely generous as long as you are applying mathematics. And that can be 10% of your grade, and then I will adjust everything else accordingly. So if there's something that you want to pursue, something you want to learn further, happy to do that. All right, just some general advice. For those of you who were in the earlier class with me, I apologize that it's the same, but oh well. So the first is being prepared. You do not know when opportunities will strike. It turns out that academics really love birthday conferences as gifts when they get old. So, when my advisor turned 61, we had a birthday conference for him. I was not one of the organizers. He had 2 Steve Millers born same year, same city. And so the other one was the official member of the organizing crew. I was just an unofficial assistant to the organizers. There was a big reception at the Institute for Advanced Study over dinner, and a couple of people were told that it would be wonderful if they could make some remarks. I was not one of the people asked. I was not insulted. But I prepared a speech just in case. And after the people who were invited gave their words, they then had a couple of people in the audience they went up to and said, would you like to say a few words? And if they ask you that, what's the answer? Of course, you have to say something. And so I ended up having the microphone handed to me. One of my friends snapped the photo for me. I had prepared a speech just in case. It's much better to prepare and then not use it, and then to be put on the spot. Good advisor. You don't want to look foolish like that in front of people. When you're doing job interviews, learn as much as you can about the company you're going to. See who might be there to talk to. When I was applying for the job at Williams and other schools, I had a piece of paper for each school listing the names of all the faculty in math and 1 or 2 sentences of what would I talk to them about. This was before really good smartphones. And before each meeting, I would just go to the page for that school and quickly look down because I did not know who I was going to meet with. Your job, be prepared for class, do the reading, think about the material, come to me, the TAs, or each other if you have questions. Unfortunately, for those of you who are juniors and seniors, you might remember the good old days of Bronfman, where our offices were around a library. That was a great place to work. There is the basement in Bascom. I know. And unfortunately, my face is now on the tape, so I will have to edit that later. Thank you so much for that note. So we can make it a great place together. No. But there's also the common area on the first floor. Again, these aren't the best areas, but you're welcome to work there. And then if you have questions, feel free to come to my office. I cannot have chairs outside my office. That is a fire hazard. Lots of things are fire hazards. My job is to provide resources, guiding questions, and to be available. So if you have questions, come to me, come to the TAs, come to each other. Strongly encourage you to form study groups. So 3 pieces of advice from my brother. First is party less than the person next to you. Nobody is sitting, I think, by the, well, no, I guess. So one person is going to have a really productive, 2 people, maybe productive academic semesters. Take advantage of office hours and mentoring. When you get into the real world, you may not be in a company that has people who will spend a lot of time on your development. This is one of the advantages of going to a liberal arts school is, for the most part, we try to make sure people don't fall through the cracks. And then the last is learn to manage your time. No one wants to. Things will happen. I remember in college, one of my friends tried to kill himself a week or so before the semester ended. And all of a sudden, I had much less time than I expected. Things will happen to you or to the people around you. If you can get a strategic reserve of 1 or 2 weeks of material, then as life happens throughout the semester and you chip away at that, maybe you can end the semester right on level. So as much as possible, I urge you to have a horrible weekend. Read as much as you can in a variety of classes. Build up that reserve, and then when you hear the lectures, it's not new material, it's a bit of a review. This does not mean if I decide to play hooky that you can give the lecture. But if I'm giving a lecture on Stirling's formula, what should you know before the lecture begins? What is Stirling's formula? All right. I'm also happy to do practice interviews, adjust deadlines, as I said. So, for those of you who are going for jobs, if you've never done an interview before, you really should do a practice interview with a friend, with somebody from career services, get some feedback. If you are doing an interview by Skype, you have a huge advantage that you don't have in person. What's a huge advantage of a Skype interview that you can do?
Paper?
Yeah, you can have paper either in front of you or behind the screen where things are written. They can't see it. So be aware of what environment you're in. If you are interviewing, get the name and the email address of whomever you talk to so you can send a thank you note later that day. Thank you for taking the time to talk to me. I hope this is readable. One of the big questions is, what is the right statistic to look at? So here you have 2 different websites. I'm not saying which ones they are, but they're standard ones, either MLB or ESPN, something like that. And here, Boston Red Sox are 41-19, 683 winning percentage, no games behind. New York Yankees, 37-17, 685 winning percentage, 1 game back. Over here, the Yankees are listed first at 37-17, 685 winning percentage, 1 game behind. And the Red Sox are listed second, no games behind. Who is in first place? The Red Sox or the Yankees? Yes?
I mean, by the MLB standards, the Red Sox.
By MLB standards, the Red Sox. A win is half a game plus, a loss is a half a game minus. The Sox played 6 more games than the Yankees, I believe, at this time. And they went 4-2. That's a 666 winning percentage. That's lower than the Yankees' 685. So it dragged the Red Sox down below. So their winning percentage is lower than the Yankees' winning percentage. So depending on how you look at things, you can easily adjust the conclusions. Here's one of my favorite examples. Imagine I tell you a team has won 3 of their last 4 games. Is the team playing well? They've won 3 out of their last 4.
What sport is it?
Say baseball. I mean, almost any sport I would take 3 out of 4.
They probably won 3 3 out of 5.
Ah, they won 3 out of 5. So if you looked 5 games ago, they must have lost. Otherwise, what would I have said? They won 4 out of 5. So you know, 3 out of 4 is a 750 winning percentage. They really only have a 600 winning percentage. What else do you know if I tell you they've won 3 out of the last 4?
They won game 4.
They won game 4. Because if game 4 was the loss, then I would have said they've won 3 in a row. So really what I'm doing is I'm looking at it just properly. And by looking at it just properly, I do the best I can. So much of it is, can you look at things the right way? And a lot of statistics or probability is how do you color things to make your point. And I want you to be aware that this can be done. What do people see? Be more specific. 2 giraffes, okay? This is a 3-dimensional sculpture. I'm going to play as the camera walks around. It jumped. And so from that point of view, it's now an elephant. So again, if you look at things just the right way, you can greatly mislead people. Now my goal, of course, is not to have you misleading people, but to be aware of when people might be doing this to you. Be very skeptical about the information people give you and how they choose to present it. If you could find the right way, how many of you looked at like log plots? And we'll do some of that because if you look at data the right way, relationships that are initially hidden become a lot clearer. All right, gambling. Officially, I discourage you from gambling. This is meant to be a theoretical exercise. Unless, of course, you profitably apply it, in which case I want you to remember where you learned this stuff from. All right, so in 2007, a friend of one of my favorite students bet $500 at 1,000 to 1 odds of the Patriots going undefeated and winning the Super Bowl. Anybody know what happened to the Patriots that year? They went undefeated in the regular season and lost a very close game in the Super Bowl. This is actually one of 2 interesting bets friends of students of mine had. In the first year the Patriots won the Super Bowl, before that year began, one of my students had an uncle who was in Vegas, got really drunk, and woke up the next morning to find out that he had bet $1,000 on the Patriots to win the Super Bowl that year. And to me, the amazing thing is he actually saved the ticket. So, do you think this is a good bet? 1,000 to 1 odds to go undefeated and win the Super Bowl. Do you like those odds? Do you think that's a fair odd? Yeah.
Well, I mean, there have been way more than 1,000 like team seasons, and no one has ever done it in like a 19-game season. So you could say
Right, but again, in a lot of those team seasons, is there anybody here who is a Cleveland Browns fan?
Try to be.
All right, as long as you're saying try to be, then I don't feel like I have to be too polite. But there are teams like the Cleveland Browns, and I don't really want to count Cleveland Browns as generating a true NFL season. You know, they may win a game this year. It's possible. Things can happen. But so, you know, you want to look at a really good team. Because, a team that's average, they're not going to have a chance of, the Patriots were a really good team. Yes?
I mean, from our perspective now, this seems like a great bet. Like, I would take this.
Right now this year?
Well, now I would not. But it seems like the odds are really good for when you compare it to the results.
It's just one loss is enough to eliminate this. And you've got at least 3 playoff games to get to the Super Bowl. In fact, exactly 3, including the Super Bowl if you're going undefeated in the regular season. I don't think 1,000 to 1 odds is a fair amount. I would want much more before I'd be willing to do this. Or have a much smaller bet. So I don't think these were particularly great odds, but the person makes the bet. So because I'm not going to be balanced throughout the rest of the year, I will be balanced right now, and I will show the helmet catch in an interest of fairness to those of you who are New York sports fans. Enjoy it now because this is the last time. All right, so the Patriots did not win the Super Bowl. They came extremely close. All right, in the third quarter, with the Patriots leading, Vegas calls the person up and offers to buy back the bet at 300-1 odds. Go Bills! What was the bettor's mistake? Yes?
Should have bet on the Giants.
Should have bet on the Giants. Right? At the start of the season, there are so many teams that you can't really guarantee a profit by betting on everybody. Somebody has to pay for Mr. and Mrs. Smith's suits. Vegas gets a cut. And in fact, when Vegas gives you odds of a game, and they say, Patriots by 3 or Eagles by 7, they're not saying, we believe that this is what will happen. What they're saying is, we believe this is the amount we need to give so that half the money goes one way and half the money goes the other way, and then we take the money from one half and give it to the other while taking a cut from each. Vegas tries to equalize the betting. What some professional gamblers do is they have people whose job is to place bets because they're not known, and they don't want it to be known that they, a major gambler, is making the bet. And what they might do is they might have somebody put down a bet for $10,000 to move the line. And they'll put $10,000 for the game to say Team A to win. And then the serious gambler will have his other compatriot put down $100,000. Now the line has been moved a little bit more favorably. So there's absolutely a lot of great manipulation that's done here. They should have bet on the Giants because at this point there's only 2 teams left. So let's analyze this. Let's do a really simple model. So you always do simple models first, and then you see how can we make it more complicated. Do we capture enough of the world at this point, or do we have to worry? How many of you are familiar with Galileo's experiment where he drops 2 masses from the Tower of Pisa? Okay, what were their colors? Okay, why does that not matter?
Touching the mass.
Yeah, he's testing to see how fast they fall as a function of the mass. Does the mass really matter? Do you think the color matters? Maybe if one was black and one was white and they were sitting out in the sun for a really hot day and one of them was now hotter than the other, maybe the hot one might go through the atmosphere in a slightly different way. But if they're both at room temperature, the color shouldn't matter. So that should not be a factor I include in my model. You want the simplest possible model, and then you tweak it as needed. So here, let's assume the Pats win the game with a probability P, Giants with a probability 1 minus P. We'll assume there's no tie. We'll assume if you bet $1 on the Giants, if the Giants win, you get X dollars. You've already bet $500 on the Patriots. Now you bet B dollars on the Giants. And you can look at your expected winnings. Okay? And so, it's a nice linear formula. The more I bet on the Giants, the more this helps me if the Giants win, but now I've lost a certain amount of money. So when you look at this, do you want to put down a significant amount of money on the Giants? What's your objective? So if you're gambling, what are you trying to do? Make money. Is it as simple as make money? You also want to minimize your risks. Which would you rather do? Have a 1 millionth chance of winning $1 million, or 100% chance of winning $100? How many people would take the $100? The certain $100? How many people would take the 1 in a million chance of winning $1 million? A lot of this depends on your personal finances. $100 is not going to change your life. $1 million, if it doesn't change your life, please talk to me after class. Okay? Most of us, $1 million, that would change our life. And so you know what? $100 is really not going to change. I'm not going to go for the 100. I'm going to go for the million. And so you really want to think, what is going to make a real difference? And so here, by hedging, you can ensure a certain amount of winnings. So here I chose P equals 0.8 and X equals 3. So for every dollar you bet on the Giants, you get $3 back. And then I plotted what is my guaranteed winning. So I don't care if the Patriots win or the Giants win, what's the minimum I will get no matter what. And in this model, you can see you can guarantee yourself with these numbers roughly $350,000. That's less than $500,000. I would much rather have $500,000 than $350,000. If you cannot do this algebra, you do not belong in this class, okay? Basic algebra. But I would much rather have a certainty of $350,000 than if the Patriots lose, I get nothing. You're going from 500,000 to 0. That's an incredible drop. So for something like this is a trivial calculation. If that person had been aware of this when Vegas called, when he just said this, I'm not going to sell you back my bet. I'd actually like to place a bet on the Giants right now. And again, $350,000, that's life-changing for this person. All right. How many of you have not programmed in any environment? Okay. So what I want to do is I want to make sure that everybody has some basic programming skills. I often do Mathematica for stuff like this. If you've done R in your other classes, that's absolutely fine. But you need to be able to write simple code to simulate things, to build intuition. And so this is just some Mathematica code to just do the plots here and get some sense. And then one of the things that you can do very nicely in Mathematica is they have what's called a manipulate command, where you can actually have the graph and then you can adjust the shape of the graph by changing the probabilities or the payoff matrix. So it's really nice to be able to see these things. Yes?
Can you do that in R as well?
I'm not sure. I don't really use R. Does anybody know if you can do that in R? Where you can have a graphical display and then you can manipulate in real time by sliding things.
I don't think you can.
Okay.
You could if you use like a very advanced package called like RShiny. It's like interface.
And in fact, we are going to have 3 people from the analysis group in Boston coming on Wednesday. I think it's going to be a pizza lunch around noon. You are all invited, and they're going to be talking about things you can do with RShiny. And again, the ability to present information well is extremely important. Right. If those of you who are interested, I have to balance off the Giants. Okay. If you are interested in applying math to sports and things like that, let me know. There's a bunch of people doing that. I sent you an email about a possible data science club here. There are a lot of opportunities for doing stuff like this. Okay, clicker problems. We have about 10 minutes left. Any general class mechanics questions right now? Okay, and then the talk today is at 1 p.m. in Physics 203. How many of you have heard of the birthday problem? How many of you have not heard of the birthday problem? Okay, wait a minute. How many of you are asleep right now? Because the 2 sets did not union to the entire class. How many of you have heard of the birthday problem? Okay, how many of you have not heard of the birthday problem? Okay, so most people have heard of the birthday problem, so I'll do this somewhat quickly. The question is, how many people do you have to have in a room before you have a 50% chance that 2 people share a birthday? There are a lot of implicit assumptions in this. What's one of the implicit assumptions?
Everyone has a birthday.
That is an implicit assumption. Be a little bit more specific than that, though.
There are no twins. People's birthday aren't reliant
Okay,
on anybody else.
people's birthdays are independent. My wife is an identical twin. So if I'm at a family gathering on her side, it is quite likely, yes.
Even distribution.
Yes, I'm not going to get into the biology aspects. I will save that to other departments, but we will assume that birthdays are evenly distributed across the year, which is not necessarily a true assumption. There's a great passage in the textbook from Malcolm Gladwell's book, which one was it? Outliers, where he takes the birthdays of the players of the Canadian Junior Hockey League Championship and uses those birthdays instead of their names. And it's all clustered in a short period of time, like 3 months. And the reason is when you're a little kid, if you want to excel in sports, it's sad, but you want to be the oldest kid to just miss the cut for a level, so that you'll be one of the biggest kids in the league, because when you're young, that makes a huge difference. And then you look better. So the coach gives you more playing time, and you get more, and it just propagates. And it's amazing how far this propagates. it would be interesting to compare this and do admissions to college. Does it make a difference when you start kindergarten or first grade? How correlated is something like that? A couple of years ago when I was doing a recruiting event for Williams, one of the Windows on Williams events, I convinced the director of admissions that if there were not 2 people at the event with the same birthday, Williams would give free admission to everyone at my table. I didn't tell my wife at the time, but part of my negotiations with the director of admissions was that I would have to provide some of the funding myself if this had to happen. I believe I've since told my wife how much we were potentially on the line for. But boy, were those students excited going around finding people's birthdays. There were well over 100 people in the room. I was not worried. The director of admissions was, I think, reassured with my calculations, but I think there was a little concern. So, the question is, how large must N be for at least 50% of the people, for there be at least 50% of chance that at least 2 people have the same birthday? I'm not even going to bother doing it in this class. There are so many people here, it would be shocking if it were not true. Maybe we'll do it if we have a moment or two at the end. And so since so many people have done this, I'm not going to go through the analysis with clickers. Can anybody say, a la Monty Python, which number is right out? I'm sorry? No. I'm sorry? 500 is right out, right? We know we don't need as many as 500 people to be assured that there's a 50% chance. Right? Why is 500 absurd? Yes?
You have 100, it's
Yeah, once you get to 366, you're fine. Is there anybody here who was born on February 29th? I have an agreement with admissions that they will not admit anybody born on February 29th, or if so, they are not able to take my classes. Because it makes this problem a lot harder because the February 29th happens every 4 years. So there's really only 365 possibilities. Once you get to 365, it's possible that nobody has shared a birthday, but extremely unlikely. What about 180? And again, this is what I want you to be able to do, get some quick, rough intuition. Do you think 180 is enough to guarantee a 50%? Or do you think it's much more than is needed? Much more. If you look at the marginal benefit of a new person coming in, if nobody has the same birthday at this point, the next person would have about a 50% chance. And it's quite likely that by the time I hit 180, I've already got a reasonable chance of getting a 50%. So 180 seems too large. These numbers here becomes much harder. The actual answer is around 22. And if you look at a plot, you can see the 50% is coming around 22. And then the question might be, what if you try to generalize? What if you go to Pluto? Anybody know roughly how many days there are on a Plutonian year? A lot. I think it's about 90,000? 90,520 days. So the question is, how does the number 22 generalize to Pluto? And so in the book, I go through the calculation using elementary calculus. So I know this might be shocking, but calculus can actually be used to solve problems. How many of you have taken Calc 2? Well, this is, again, one of those questions where your hand should be up. You should have taken Calc 2. If you haven't taken Calc 2, take it and talk to me immediately. What is the main thing you do in Calc 2? You do? I can't hear you. I'm sorry? I don't think you do derivatives as the main thing in Calc 2. I think derivatives is more Calc 1. You should be learning integration techniques in Calc 2. Right? How to find areas under curves. Did your teachers ever tell you why we care about areas under curves? So we care about areas under curves because areas under curves are often probabilities. And they tell you the likelihood of something happening. So we will see lots of curves this year that are probability distributions. And then the area from the curve from, say, maybe 3 to 7 will be the probability that you get a value between 3 and 7. Only once in my life has someone come up to me and asked me for the area under a curve. And I was in Berkeley, and this is a strange place. But I have been asked many times to calculate probabilities. Some of you have had classes with me in the past. What is the big lie in Calc 2? Yes? That you can integrate. You can't integrate. If it makes you feel better, I can't integrate. Professor Garrett can't integrate. None of us can integrate. we can only do special, very nice functions. And we have to work really hard to give you functions that can be integrated in nice closed form. If you start getting into 2 dimensions and higher, yeah. So you have to go to numerical techniques to approximate things. Fortunately, the small class of functions that can be integrated nicely turn out to model a lot of real-world problems to a close enough degree that we're okay. And so the real question is, how does things change? And so the book, we go through and we do the calculations in detail. I could have done, it actually goes like the square root of the number of days. And it's a nice calculation to see why it goes like the square root. All right, so I'm going to stop the recording right now.